Welcome to security testing in GitHub workflows, where we'll be covering how you can use StackHawk's pull request checks to add security testing to your existing developer workflows and help your team ship secure software faster. So my name is Nicole Jones. I'm a marketing manager here at StackHawk, and my co-hosts today are Senior Product Manager Brian Erickson and Senior Software Engineer Brandon Ward. We're honestly super lucky to have them on this session today because they are the experts when it comes to this functionality. Brandon was the product manager for the pull request checks feature, which is our latest addition to our GitHub integration. He was also a developer himself for 10 years. So he was the perfect man for the job. And on the technical side, Brandon was our lead developer on this functionality as well. He's been a programmer for 8 years, so he lives and breathes the software development lifecycle. And when he's building out these features, he doesn't just think like, how am I solving this for customers, but also like, would I actually want to use this as a developer? So super happy to have them with us today. So real quick, I'll just run through what we've got in store. I'm going to kick things off with an overview of how we do web application and API security. Currently, spoiler alert, it's not working. So we'll touch on that as well. We'll also give an overview of what StackHawk and dynamic testing is for those of you who are new or just need a little refresher, because who doesn't? And then we'll dive into all of the cool things you can do with StackHawk and GitHub, including a live demo of the pull request checks feature, which, as I mentioned, is the most recent addition to our GitHub integration. And then we'll wrap things up with Q&A at the end. So feel free, please actually drop your questions into the Zoom Q&A box at the bottom of your screen, so we can answer those questions either during the session or at the end. So we want to kick things off with just a little question. Raise your hand either in the comfort of your own home or office, or feel free to virtually raise your hand in Zoom. So raise your hand if you use pull requests as a way to ensure that you are shipping quality code to production. So just nice. I see some hands already.
And I know we do here at StackHawk.
Perfect. All right, so we'll just kind of keep that in mind as we go through the session today. But let's start things off with how security typically happens for us currently. So for a lot of organizations, security testing happens on a weekly, monthly, quarterly, or even annual basis, either in the form of pen tests or even using an antiquated tool that's sort of just kind of like click and scan. This testing mostly happens in production, even if you are using some security tooling, just because the scan times with those tools take too long and the tools are too difficult to implement in CI, even if they say that they do. So on the flip side, what happens for a lot of orgs is they just may forego testing altogether because it causes a blocker to software development. So like I alluded to in the beginning, these processes aren't working. So why is that? Well, for starters, security is vastly outnumbered by developers with a ratio of 1 to 100. So that's one security person trying to keep up with the work and continuous changes of 100 devs. There's no possible way they can keep up. It's not scalable, and it's disruptive to product delivery. Because what ends up happening is, I mean, we all know software doesn't slow down for anyone. So those bugs are making it into production, whether anyone likes it or not, security or devs alike. And that means that those fixes are also happening in production. Brandon, have you and your developer experience ever had to go back and fix code that you either wrote months ago, or maybe you didn't even write and you've been tasked to go back and fix?
Yeah, definitely. When those security reports come out, it's always a fire drill to get them fixed as quick as we can.
Right. And those fixes are not cheap. They actually end up costing about 25% more than they would in or prior to production, which involves quite a few other things. Brian, can you talk about like what else is impacted when we try to fix things in production?
Yeah, and as Brandon said, it is really disruptive. When these come in, they're typically really high priority. They're found in production, and they disrupt our sprints and our product roadmap, and really ultimately our ability to continue to deliver value to our users. And that's just not something that that we want to continue to do.
Exactly. So that 25% increase in cost accounts for all of those ways that it disrupts product delivery, whether it's from, a roadmap point of view or a sprint point of view. There's a lot of factors that are involved. So where do we go from here? Well, if we look at how normal software development workflows work, they essentially enable developers in their normal environment and existing workflows. If there's a syntax error, it won't compile. If there's a merge error, the code won't merge. And even if it makes it past those two tests, those two first checks, and there's still issues, we have unit tests and aggression tests or end-to-end testing to let us know that the code has flaws before it reaches production. Brandon, with those things in mind, like where and when do you usually get feedback on like syntax errors or merge errors?
Yeah, the feedback loop, it always starts as quick as we can. So we'll get syntax errors right in our IDE and with our build tools. We'll get unit test errors, both when we're running the test locally and when we push them up to our CI environment to run them there. So it's all about that fast feedback loop.
Right. So it's more, you're getting more like real-time feedback with those systems in place. But for some reason, when a team introduces a vulnerability, they have no idea because nothing tells them.
Nicole, actually, I think I've got the answer to your problem. It's called dynamic application security testing, the StackHawk way. So why do we at StackHawk think that dynamic testing is important, and why do we feel you should invest in it first? It's really because it helps you prioritize your efforts. It's testing against your running application from the outside in, telling you which vulnerabilities are discoverable and exploitable from the outside. You may have heard of other security tools. There's a lot of them, specifically software composition analysis and static application security testing. Those will reveal the same set of problems and a whole other set. And the challenge can be knowing what is actually exploitable. And that's where dynamic testing can really help. And so how does it work? It's an HTTP endpoint testing mechanism. So it can be run against your web app or your APIs, and it's language agnostic. So whether you're writing in Node, Rust, Java, Ruby, or any other development language, your team can focus on getting to features to market how you want, rather than worrying about whether your security tool is going to work with the code, the programming language that you want to use. And as I said before, it's going to show you how a hacker would exploit this vulnerability, so your development team can recreate the test and find the fix faster. And that's what StackHawk's all about, is getting your vulnerabilities found and fixed. And so for myself as a product manager, I think we've all, whether you're in product or any other department, are used to getting these vulnerability reports every quarter, or more recently, even getting emails from bug bounty researchers that are pointing out an exploit in production. And the funny thing is, a lot of those researchers are just using the same kind of tools that we're talking about here. They're using dynamic testing tools to scan your application. And I guess my question to Brandon is, would you prefer to find out about your security issues in your code yourself, or in production from, say, a bug bounty email or a pen test report?
Heck yeah, if I can be in charge of finding that while I'm working on the code, sounds way better than that fire drill after the fact.
Yeah. So the knock on dynamic testing in the past, because this has been around for a long time, is, or we also can kind of call it DAST is the acronym. It's a high cost to implement. Typically, they scan only a fraction of your application and at a snail's pace. The tests, as we've mentioned, are run periodically, so quarterly or weekly, and the vulnerabilities are only found after they're shipped to production. So how is StackHawk DAST different? So we are set up with simple configuration as code. So it's as simple as a few lines in a YAML file sitting alongside your application code base. It can be run by a developer against their development environment locally or in CI/CD. It's rapidly testing and tuned to test HTML applications, REST, SOAP APIs, and GraphQL. And as I mentioned, it can be automated to integrate with your CI/CD so that every time new code is pushed to be merged into your code base, that the scan can run. And really the ultimate goal here is to find and fix issues before they get to production. So just for a minute, let's talk a little bit about the software development lifecycle. I'm sure we're all familiar with this, this graphic. And so development teams have really over the last several years moved from these slow monolithic releases and broken down their applications into smaller microservices. And CI/CD tools have really come along to help ensure that code can be built, tested, and released faster than ever before with quality. And Brandon, let me ask, how does your team make sure that the code you've written can be merged and deployed to production quickly and with quality?
Yeah, it all comes down to that pull request. So that's our first line of defense, and it's where we get some manual feedback along with running all of our tests, from linting to unit tests, all the way up through security tests.
Yeah, that's awesome. And that's what we at StackHawk saw as an opportunity to really help move towards a more developer-first security solution, with giving developers the context they need right in their existing CI/CD workflows, and specifically within the pull request, where the team is collaborating to make sure the code that they put out is quality and isn't going to have issues when it gets out into production. So let's just talk about a little bit of how StackHawk and GitHub are working together today. So first off, we've got our GitHub action, which helps get your application security testing happening in CI/CD alongside your other workflows. We've combined the dynamic testing with static security testing, so through GitHub CodeQL, so you can see which vulnerabilities are exploitable and where in the code they exist, and get in there and fix them faster. And today we're going to be talking about PR checks and giving your team a comprehensive understanding of the security issues in their updated code right where they're working every day in the pull request. So why PR checks? So it's all about context, timing, and focus. So context means knowing what was the state of your code base when the security test was run. Timing is about seeing the status of the test when it starts. And if you've configured build thresholds, you can know whether it passed or failed based on if you have a high vulnerability, make sure that that code doesn't get merged into and deployed to production. And Focus gets the scan results right where your developers are collaborating in the pull request, and give you links back to how to fix the issue and into the StackHawk platform for more details. So how does it work? So getting it set up is really just a few steps. Obviously, you need to have a StackHawk account, and everyone can get a StackHawk account with a 14-day free trial of our enterprise plan. And all the features we're going to talk about today are available on our Pro or Enterprise plan. Once you've signed up for an account, we have a really easy walkthrough that'll help you get your application under scan. And as I mentioned before, it's simple as a YAML file with a few configuration details. Then you'll need to connect GitHub. So we've got our GitHub application in the GitHub Marketplace. You can install it right from there and even get an account straight from there. Or if you're in the StackHawk application, you can install it from our integrations page. Then you'll need to map a repository to your application. So that's just telling us what is the code that's related to your application, so that we know how to associate the PR with that. And then you'll need to make a couple of minor configuration updates in your CI/CD to provide the commit hash and branch name. And finally, you kick off your scan in your pipeline, ideally whenever new code is committed to a pull request. So when that happens, you'll see the flow below. Your scan will start, and once the scan starts, the commit status will be updated to in progress, so that everybody knows as they're reviewing the PR that a scan is being run against it. And then when the scan completes, the commit status will be updated with success or failure. And as I mentioned before, if you configured those build thresholds, you will see that updated, and that will prevent everyone on the team who's reviewing the pull request will know that that they should maybe take a moment and figure out what's going on. And finally, the PR comment will be added into the pull request so that you know what was the results of the scan, and including all the details of the vulnerabilities found, so the team can jump in and fix those issues, resubmit it. The scan will run again, and you'll hopefully get a green check mark and get to move on and deploy that code to production. And so Brandon's going to walk us through that process, and we'll get to see it in action.
All right, I'll pass it to you, Brandon.
All right, let's see. Can you guys see my screen? Perfect. All right, so just to reiterate some of those setup steps that Brian was talking about, I've got the StackHawk GitHub integration installed, and I have my repository mapped to my application under scan. Over here in the project, I have my CI/CD pipeline passing the commit SHA and branch name into the scanner. And then in my StackHawk file, I have the failure threshold set and I'm consuming those GitHub configuration pieces. So if we jump over into this pull request that I've got going, you can see that we've got our scan details right here on the pull request. And right now, if I tried to merge it, it's blocking me because the StackHawk findings over threshold alert tripped, and it's marking this as a failure. So we've got one high finding. If we drill into this vulnerability details, we can see that it's actually SQL injection. So this feels pretty important to fix before we go ahead and merge this in. If I pull up the details in StackHawk, we can get the same scan details right here. We can drill into the SQL injection, and right away we're getting some important information about what's going on here. So it found it on this search path. If I flip over to this GitHub CodeQL tab, which is pairing the SAST scan details against this dynamic scan, the SAST scan is alerting on two files, this user service and this search service. But since we only found it on this search path, that's a pretty good indication that I need to go into the search service. So if I pull up those details there, once I get Zoom out of the way, one sec. All right, there we go. Can jump in and see right where GitHub CodeQL thinks the finding or the vulnerability lives. So let's go over to search service on line 39. So if we jump into the code right away, we can see that we're building a query from supplied inputs just as a raw, unsanitized string, which we know can lead to SQL injection issues. So let's go ahead and fix that. Comment out this, and we've got just a parameterized or prepared statement over here just to sanitize that SQL string before it runs. And then before we commit this, let's actually test this locally. Since security tests, to make sure we've got it, like with all tests, we want to run it locally before we commit it. So I'll restart the application. And then we have a new feature in the StackHawk platform from the scan that lets us rescan. Oops, got to get to the right scan. We can rerun the findings with our rescan functionality that just lets us quickly validate only the plugins that were alerting the first time to double check that we fixed what we're trying to fix. So I'll copy the rescan command, and then I'm going to pass it the same configuration files that we used in our CI/CD pipeline. And this will trigger a rescan only on the 5 or 6 plugins that alerted the first time. So it's going to go ahead and just test what we need to test, which is super cool and super quick. So as you can see, the first scan took in this example environment about 15 minutes, but the rescan, since it's a lot more focused, should take a lot less time. We can watch it in the StackHawk platform. And then when this fires up, you'll see right away that it's looking at a lot fewer vulnerability or a lot fewer plugins to test against. So right away, the first thing it goes into is SQL injection, since that was the first plugin that alerted in the scan. So we'll wait for that to complete. As you can see, it's hitting my application locally. And we're almost there. Lots of things happening right now, so feel free to ask questions as we go. And so far, it has not found. Oh, go ahead, Ryan.
Why is being able to run the scan with just this smaller set so important for developers?
It really enables that faster feedback loop. So running the entire scan can take a lot of time. And so trying to wait 15 minutes just to see if I fixed this locally before committing it is a big time sink. And so if I can just rerun what I need to rerun, it's a huge win. So this should only take about 1.5 minutes, maybe 2 minutes, which is a big win. So as you can see, that's the scan is wrapping up. There is no high finding now because we've fixed that SQL injection bug. So we're ready to commit. So I'm going to go ahead and just commit this really quick. Oops. Maybe. I'm having some issues pushing that, so I'll work that out, but I want to just highlight this from the rescan really quick, that the SQL injection was detected as fixed from the previous scan. So this is just another touch point that we know that we fixed this before we're going to go ahead and commit this up. So it's super cool in that regard. And then let's see if I can get this working.
This is the beauty of live demos, right?
Pretty much. Yeah, we have that. This should be okay. Maybe it needs this. Maybe now? Well, I guess under pressure. Oh, there we go. So that should be good to go now. So now if we flip back over, yeah, awesome. Must not have updated it from the main branch, but as you can see right away, we pushed up our fix and now it's going to get another build, another test, and then most importantly, it'll run another Hawk scan so that before we merge, we know we fixed those vulnerabilities and everything's good to go. So at this point, while we're waiting for this, and we'll see if it completes, it takes a little while on CI/CD, but are there any questions that folks have?
Yeah, we got a couple questions, Brandon. So the first question is, do you build your application as part of a PR pipeline before scanning? How does this step look for complex applications?
Yeah, so for this particular example, I can drill into this build file. So this application depends on a Postgres database to run for the scan. So in my GitHub Actions build script, I'm running that Postgres database. And then as part of the CI/CD pipeline, we're building it first, which runs all of those tests before we actually launch the application locally in CI/CD before we scan. And so my recommendation for a complex application, if you can Dockerize the stack that it needs so that you can run all of those dependent services next to the application under scan, that should be able to get you going in your CI/CD environment.
I'm not sure. Oh, go ahead, Brian.
I've got a quick question. So you're showing this through GitHub Actions. Is it possible? So we use Circle CI for our development environment. Does this work with other CI providers?
Yeah, definitely. So the thing that makes this work is somehow getting the scanner that commit SHA and branch name. And so most CI providers have that Git metadata. So as long as you can provide those details to the scanner in the form of the StackHawk YAML right here, just through the commit SHA and the Git branch, you'll be good to go.
And just to follow on to that, can I get the benefits of commit statuses without the pull request comments if maybe we aren't using pull requests every time?
Yeah, definitely. So I've got another project where I don't have any open pull requests, but right here, if you're using the commit statuses, you'll be able to see on your main development branch the last completed Hawk scan. And so right away, you can keep a pulse on the state of your application, even without pull requests.
That's great. So I can go back and see what the status of the code was when a vulnerability was introduced. That's really awesome.
Yep. And right from the repo, you can get directly back into that scan and just see what was going on at that exact moment.
And last question for me, if some of my repositories, we're kind of moving off of GitHub or off of Bitbucket onto GitHub, but we still have some things in Bitbucket. Is this possible to use any of these features we're talking about today without GitHub?
Yeah, so as long as you're providing that Git metadata to the StackHawk scanner, what you're able to do is the StackHawk platform will show those tags. And so you're able to cross-reference the scan with the Git history and the point in time that you were scanning right back to the code.
Great.
I have one more question from the audience that I think was pretty particular to when you were doing this demo, Brandon. Do you scan the whole application, or can you choose what to scan depending on the commit?
Yeah, so this is scanning the whole application. And I think in general, just with the microservices world, that's the best approach, is to rescan the whole application. Now, the rescan portion, how that was working under the covers, is it only reran the plugins that alerted. So a quick example of that, if I show the plugin summary that was ran on the rescan, it was just these 3. But then if we look at the plugins that were run on the initial scan, it's going through a lot more. But yeah, the high level is we're scanning the whole application each time, but then to focus it down, rescan is great for local development.
Perfect. How are you looking on your scan time right now? Do you have time for one more question?
Yeah.
Are you ready? Okay, cool. So the next question is it always viable to run DAST for each pull request? Because some complex web apps might require more than 1 hour to complete a scan. So is there a predefined limit for PRs or else?
I think that's kind of up to the team and how they want to work. So you'll still get pull request checks, for example, even if you merge this before the scan is complete, it'll drop a comment when it's done. And then, as we alluded to before, you can still keep track of the state of your scans here once it's been merged. But yeah, I mean, it's kind of up to the team how long they're willing to wait for this. But if there's a way that you can run maybe a light scan or some constrained version of the scanner on PR to get some of that immediate value. But I don't know. What do you think, Brian?
Yeah, I think, we typically recommend that you're kind of scanning each component of your application and whether it's just an API or a specific microservice. But if you really have a very complex application that does take a long time to scan, I mean, one of the options is to allow the scan to run, and the PR comment will still be added to the PR after it may have been merged. And while we don't, recommend that you merge unscanned codes to production, it will kind of work in that way and can help you at least keep track of like when vulnerabilities may have been introduced and get development focus onto those as soon as possible.
And then
Right. I was just going to say, and correct me if I'm wrong, it's still delivering all that feedback in like a centralized location where developers have complete visibility instead of they push this code to production. Now it's getting flagged in some external tool that they may or may not know about and have to revisit. It's still going to show up. That feedback's still going to be delivered like where they're working on a continuous basis.
Exactly. The goal is to make this information visible right next to the code. And so it looks like this is still running, but we have gotten past the SQL injection test. And as you can see, we haven't found it. So that's a pretty good indication that this is going to pass. I have a pre-canned PR just from a little earlier with the success comment. So if we drill into that, you can see this will eventually look something like this, where we don't have that high finding anymore. We can come down into the build checks and we can see that the HawkScan commit status echoes the same sentiment, where HawkScan's completed and we didn't trip the failure threshold. So we'd be good to merge. And then, yeah, are there any other questions around this, or should I give the screen share back to you, Nicole?
I think I'm gonna let you keep screen share just in case we need you to show some things. But yeah, we're gonna dive into the Q&A section. So please drop more questions in. We would love to answer them. We also got some questions ahead of time that we can run through as well. But it looks like this.
Oh, sorry, Nicole.
Brian, did you have one?
I was going to say, it looks like we've got a question here. Umit is asking what makes it possible to integrate StackHawk with the source code line. So that's really about our DAST plus SAST combination. So with GitHub, we're using CodeQL. We incorporate the CWE ID of the finding from the StackHawk side with the CWE ID that are found in the CodeQL results and that's how we're able to associate the vulnerability found with a dynamic scan with the static results. And we also support Sneak as well for static analysis, and that can show up very similar to what GitHub CodeQL is showing right here. And Brandon, maybe you can take us and show us a little bit more of that.
Yeah, so I have, as Brian was mentioning, I've got the GitHub CodeQL results pulled up here, which is cross-correlating the results of that SAS scan with this DAST scan. And here's the CWE ID that we matched on. And then as you can see, I can jump into that particular code scanning result and then view the same findings that we're pulling into the StackHawk platform, but right from GitHub. So here's the example of that SQL injection bug, but the idea is with the SAST plus DAST, we can benefit from those tools because they're really good at showing you where issues might live in the code. And StackHawk is really good at showing you how to execute it from the running app. And so when you put those together, the goal is to give developers the complete picture while they're fixing it.
Sweet. Okay, let me look through some of the questions we've gotten ahead of time. So, I mean, if somebody, we kind of touched on this in the beginning, but maybe to just reiterate, if somebody isn't using PR requests, like how could they use this feature without, honestly, I don't know this word, but ephemeral environment?
Yeah,
so help me out.
Yeah, so if you have to scan to a main based off of a main branch, or maybe like only in pre-prod or only in your dev environment, then the benefit there will just be to rely on these commit statuses. So as you commit to, in this case, main, you can run your scan against that fully deployed environment on your specific app and then see the results still off of your main branch, just without the pull request comments.
And Brandon, would that work if I say have like a staging environment or some kind of pre-production environment where I, still am being careful about getting code with vulnerabilities deployed to production, but maybe don't have an environment I can spin up in CI/CD?
Yeah, definitely. The beauty of the scanner is you can point it wherever you need to. And so as long as you're running it before production, you'll still get all the benefit from checking and getting these statuses right next to the source code. So when you go to release, the goal is that you'd see this and know if you need to halt the release.
And that would also, if there was a pull request related to that, you'd also see the comment in that pull request too, right?
Yep, as long as the commit that is being scanned is the latest commit in that pull request, then it'll put the comment in there. And we did that intentionally to prevent over commenting in case for some reason you make a couple of commits in quick succession or the scan takes a while the code is changing. We didn't want to put stale information in that pull request. So it should just be the most up-to-date scan. So
All right, so on that same note, one of the questions that I've received is, as a security person, like how can, they leverage these features? How can it give them a better way to collaborate with developers? We've kind of talked about how you can track vulnerabilities as far as when they were introduced and who introduced them. So can you just like elaborate more on like how that's possible?
Yeah, so for a security person, their workflow will probably start with this commit and branch tagging, so they can see the first time a vulnerability was introduced and then use that data to work backwards into the code and figure out what happened, why it was introduced, what was happening, and then consult from there. So the recommendation there is to make sure you're adding this metadata to the scan just so that you can tie everything together.
And to add on to that, the security and basically anybody in the team who's configuring the scans can set those thresholds to make sure that to be confident that when code is being moved through the deployment process, that there'll be a pretty obvious alert that, look, something new was found. And if you're triaging your issues and making sure that, only the new things are popping up, that will be a great way for you to kind of ensure that vulnerabilities are addressed pre-production. So
Right.
Oh, I'm sorry, Nicole. You go.
I was just going to say, we got a great question that just came in. Brian, I think you can handle this one. Is this feature available for DevOps Azure pipelines?
Yeah, so StackHawk is supported in Azure DevOps pipelines. And as Brandon mentioned before, all we really need to make this feature work is the commit hash and branch name added to your environment variables as the scan is being run. And those are pretty common values that are available in any CI/CD. So you can definitely set it up wherever you need to.
Yep, we're confident you can get that data in any CI provider. Worst case scenario, I mean, if you're using a Git-based system, you have to have the Git CLI. So you can also pull that information straight from there in your build.
All right. Any more questions from the audience or questions that Brian, Brandon, you guys have come across while, communicating these features, working with customers on these features and whatnot?
Yeah, I mean, just my sentiment on this feature, it's super cool to get this information right in the development process, putting that information right where we can act on it before we're out of context.
Definitely. Oh, we got one more. What is the reference DB for CWEs?
So on the StackHawk side, we're built on top of the open source project Zap, and that is where we get our CWE IDs from. And then the various SAST tools maintain their own CWE table for the vulnerabilities that they're pinning or finding. And then when we match on those two IDs, that's how we're able to tag the CWE ID for an external SAST tool to a StackHawk scan. But yeah, the short answer is both tools are maintaining their own reference DB for CWEs.
And there is also the kind of common weakness. So CWEs stands for common weakness enumeration. There's a community developed list of those CWE IDs, and those can be found at the cwe.miter.org website, which is where a lot of them are collected, and most of the tools like ours and the SaaS tools reference that.
And then looks like we got one more question. This one might be a good one for you to answer, Brian. Is the CWE exposed in StackHawk's internal reporting / API?
It's something that we just recently released. You can now see the CWE ID in our platform alongside the issues, as well as in our reporting in our API when we have a CWE associated.
Yeah, so it'll show up here in the UI and then also in the reports. All right, should I turn it back over to you, Nicole?
Yeah, if you've got any last minute questions, still feel free to drop them in, but we'll keep chugging along. So I'll steal back the screen share. Hopefully I can still do it right. One second. Here we go. I think this is it. Okay. You guys can see next steps.
Yep.
All right. So what you can do next and what to expect from us. So the best part is that anyone can really try out the functionality that we've shown today, either if you are already a current StackHawk user on a pro or enterprise account, or you can go sign up for a free trial that gets you access to the enterprise account. And then you can install the GitHub app from there. You can try it out for yourself. Super easy. We've got great documentation to guide you through the whole process. We will also be sending out an email today with the recording for you to access, links to the docs, more defined steps on how to get started so you don't have to just remember everything that was said today. And then also some instructions on how to get some free StackHawk swag. So we are offering, if you even if you're on a trial account, if you install the GitHub app and then just give us a little feedback, we'll send you a free swag pack. So there'll be more about that in the email. And if like a customized experience is more your thing, you want to do like a one-to-one product walkthrough, our team will be in touch. So that's super easy to coordinate. And if you don't want to wait, you can always go to stackhawk.com. At the bottom of our website, there's a section to request a demo. You can kick that off yourself if you're super eager. We would love that. And as always, you can chat with us, ask questions, get help, or just learn more either on our website or in the app. If you're already a StackHawk user, we have chat functionality in there that's supported by customer success and other members of our team to get you the information that you need. Docs.stackhawk.com is always there. We have great docs if you're just ready to dive in and get some pull request checks going. That's the best place to start. Again, there will be direct links in the email that you received today. And then also we have a help center as well. So if you just have some basic FAQs, that's a great place to get started. If you don't want to, talk to anyone, which is understandable. So lots of options there, but we will be following up today with all of these resources. So that'll be available to you whenever you want. Brian, what's up?
Oh, I just wanted to add on to that. We've also got a guide that'll be coming with a link in your email that if you, for some reason don't want to or can't scan your own application, it'll walk you through step-by-step setting up GitHub Actions against a vulnerable application, kind of similar to what Brandon was showing us today, and take you through the whole process of forking that and getting a pull request and having the results show up in your PR so that you can really experience this firsthand. So keep an eye out for that.
Yes, absolutely. Thank you for adding that in. I lost my notes and I kind of started winging it. So Thanks for making sure that we covered that. All right, well, let me just double check that there's no other questions. Brian, Brandon, do you see any other questions in the Q&A?
I don't think so. I think we got it all. And I think there'll be an office hours coming up soon if anyone needs more in-depth help with this, right?
Yes. Yep. So we will have an office hours. I apologize. I'm blanking on the date. 1 second.
Thing is later next week, right?
Yes, it is next week. That'll also be in the email that you received today. So we'll call that out. It'll be a super kind of low-key technical session. So any questions that you have, if you've tried out this functionality, show up there. It's just an in-between of a demo and a webinar, and we'll just address whatever questions we can work it out right there in the session. Brian.
I just wanted to let everybody know that is next Friday at 10 a.m. Mountain. So keep an eye out for that link, and we'd love to have you join us there and dig into just how maybe you can try it between now and then, and we can help you guys through any issues you run into.
Next Friday, 10 a.m. Mountain Time. Thanks. Yeah, and we'll have a link for you to register there in the follow-up today. So thank you so much, everyone, for joining. Brian, Brandon, did I miss anything?
Nope, you got it.
Got it all.
That's it. All right, sweet. Well, thank you. Yeah, thank you, everyone. Have a great weekend and rest of your day, and caw-caw.